14.7, working with the natural logarithms. So natural logarithm of a number is its logarithm to the base of 2 point. Basically any number you select and let's say 3. Now if you write this number in terms of not 2.718283, if you use this base, then you are using natural logarithm. We use this is natural. This value also refer as e, so you can write log e to the power 3. What is e value? 2.71828. We discussed what is the specialty of this number. Um, when you draw y equal ex and its gradient graph, still the same graph. So that not for all number, um, only for this number 2.71828x and 2.7828x. If you get 2x and if you get the differentiation 2x, it is not equal to 2x. But if you take this one y equal to 1 and if you differentiate, then this they are equal. So with the shortened form we write y equal ex, dy over dx is ex. This is applicable to only this number. It doesn't work for 2 or 3 or any other number, it doesn't work. So I apply this base to 3 log 2. What is the shortened form? Log e. So we are writing simply this one as ln 3. This is shortened more further and this is ln. So when you look at it is ln, it's not a different creature. It is again the same thing. So different base, that's all. I show the specialty of that base. And all the working out is same. All the laws are same. I can write log e to the power 10 simply. ln 10. If I write ln 21, what is the meaning of that? Log e to the power 21 in terms of log. If you are confused in this L1, you can look at it in this form. Now, log 4 to the power 4x. What is the value? It is going to be x because 4 to the power x log 4 to the power 4, this is 1 x. Likewise, ln x is x. Why? Because ln x mean log e to the power. Sorry, ln ex. So ln ex is x. Why? ln ex mean log e to the power ex. It means x log e to the power e. So this is going to be 1. So x times 1 equal x. When you look at ln e to the power x is y, it is x, it's a bit confusing sometimes. But if you write to in a proper mode, log mode, yeah, it is normal then. Because it's like normal. 4 to the power 4. 4 to the power, log 4 to the power 4 base 4 is 1. So this is x times 1 is x. We know that logarithm is the inverse of exponential. So logarithms is the inverse exponential. So we have exponential ex, y equal ex. Then the inverse function of this ex is y equal ln x. Y equal ex, y equal ln mean log e base x. That is the ln x mean. So those graph behave. We know that ex as usual is going to through 0 1, and the inverse graph. So in the second book we will discuss this one, how to draw an inverse graph. So inverse graph usually we can draw when we draw a y equal x line first, y, and we'll bring a mirror, and when we keep this mirror, so the mirror reflection, so is the inverse graph. That's how usually either we have to plot taking the values or by using this tactic. We want to bring a mirror and we want to keep on y equal x, and then we want to find the mirror reflection. So it is going to be, this is going to be 1 0. So this is y equal ln x. So y equal ex, and its inverse function is this one ln x. If you want, we can check this one. We'll do experiment. Let's take take x equal to, then what is e2? E2 is 7.38905.6099. Now I will put that one to this value to here. Then I should get x. So y equal or ln x equal ln 7.38905.6099. Then I should get 2 back. I put into the 2, and from this one I should get, when I substitute this number, I should get 2 back. Yeah, check with the calculator ln, type in this number, you will get 2 back. Do this experiment and see. Example 17 a ex equal 5. Now you can work in two ways like this. First of all, by looking at the first principle. What is the first principle? Um, this is the power. This is the this is the power. This is the base. So when we apply in log base is going to be the base, and this 5 equal x. So we simply write this is ln 5 or x equal ln 5, or we consider this as an inverse operation. So I can put ln form to ex and ln form to 5. So then x will come out ln e equal ln 5, ln equal 1, x equal ln 5. So we will bring the reality of this ln. Sometime you will recognize easily what is the reality of ln. Log e to the base is ln. So ln means log e base. So log e base ex equal log e base 5. Then 1, 2, 3 out. So then x out log e base e equal log e base 5. So log e base e equal 1. So log 2 base 2 equal 1. A base a is 1. Likewise e base is 1. So x times 1 equal log e 5. So x equal log e base 5. It means what is the short term for log e? ln 5. So it's better to use to this method those the symbols. Uh, so this is the inverse operation of what the first principle. I look at this one. Like what is the first principle? I mean, for example, 3 square equal 9. Then log 3 base 9 can express as 2. That So that principle I apply for by looking at this. Now this one this inverse operation we already applied when we were doing calculations. For example, we work out in 14F example question 1a 2 to the power x equals 75. So we'll apply first principle. Log 2 base 25 equal x, or we work out differently. 2x equals 75. So we can take any base, but we stay with the log 10 base, common base, 2 to the power x. This is 10. Okay, I will write it. Log 10 75. Then this x will come out log 10 to the power 2, log 10 to the power 75. So like 10 to the power 75, log 10 2. This is a form of working. Important thing is when you work out these logarithms, you want to be in attention where is the base and where is the exponent or power. Now this is the base. So when we bring into a logarithm, it means we write x equal ln 5. Now where is the base? Where is the power? So you want to, so power is here. Now where is the base? You can't see the base here. Base is log 2 to the power 5. So base is hidden. Sorry, e to the power 5. E is hidden here, but still there. Now part B, ln x equal 3. Now the previous one we jump to the logarithm, and this one we need to come out of from logarithm. So that's all in this section, jump or jump out of. So now to get into a normal, now first of all, now we are expected to write in exponent. So where is the base? Where is the power? If you can't trace this one, then you can't make it. We know that the logarithm task is taking the power out. So this is the power. Where is the base now? Our base is hidden here because ln means log 2 e to the power x equal 3. Our base is hidden. So then you have to write x equal e to the power 3. So example 18 e 2x plus 3 equal 7. So we can come with the first principle. Where is the base? Now here we need to jump to the logarithm. So whereas the base is this one, this is our, so then we can simply write uh, 2x plus 3 log e base 2x plus 3 equal, sorry, I am also log e base 27 is 2x plus 3. This is simply ln 27 equal 2x plus 3. So 2x equal ln 27 minus 3. So x equal half a times ln 27 minus 3. Not 27, this is 7. Or this is, I draw on the first principle, or you can come like this. Or 2x plus 3 equals 7. Apply ln, natural logarithm to both sides. ln. So this is become 2x plus 3 ln e equal ln 7. So this is become 1 e to the power e. So 2x plus 3 equal ln 7. 2x equal ln 7 minus 3. X equal half ln 7 minus 3. So 2 ln x plus 1 equal 5. 2 ln x equal 4. 5 minus 1. So ln x equal to divide by 2. So x equal e to the power 2. In here, there are two approaches actually. So this is log 2 to the power e to the power x, that is the reality. So then this is the base and this is the power x. X equal, or this is another form e. I take e from both sides, e2. So then e to the power ln x become x. Here I use the theory of e to the power ln x equal x. It's coming kind of like if a inverse of b, then b is inverse a. Ln x equal 2, but you can write this ln x when goes to other side, it will become a. That's how some students keep this one in their mind, but that is not the right way of, but still it works. Right idea of it is taking the inverse or with the first principle. This is C, so we can write ex square plus, this is a quadratic form I am going to take, minus 14 equal. So ex equal, when you take y, this is y square plus 5y minus 14 equal 0. Then this is y plus 7 and y minus 2 equal 0. Y equal minus 7 or y equal 2. Now y equal 2 means ex equal to, then we'll take a log back or ln back, natural logarithm, x equal ln 2. E goes to other side, it will become ln. So that is a bad way of remembering this, but still work. It is not the real idea, but some student like y equal minus 7, then this is y equal minus 7, ex equal minus 7. So if we take the logarithms, this is going to be x ln minus 7, but this is wrong because the logarithm is not defined for minus numbers. Logarithm is not defined for my negative numbers.